Good morning, good afternoon, good evening to everyone joining us today. This is the Keshe Foundation Spaceship Institute, public teaching in English for Monday, February 12th, 2018. And this is part 2 or week 2 of exploring plasma science. We have Jim McDonald with us today and also Gatwa Wambogwa. I'm your host, Flint Mulhausen, and welcome Jim and Dr. Gatwa.
Thank you, Flint, and welcome everybody. And we welcome Dr. Gatwa today, who's going to be presenting a lot of the different definitions and terms that we all need to really understand about the plasma. It does help us in understanding the science. And so these become very important as we progress with our knowledge down the line. So I will happily hand it over to you, Gatwa.
Thank you very much, Flint and Jim and everyone else in the background. And I hope all are well wherever they are. So good morning. I'll share screen and we'll take it from there. Please let me know when it's up. Flint is my...
Yes, we see it there.
Okay, thank you very much. So today I have 11 basic plasma science terms. Because plasma science is new, we need to understand these terms in order to understand the texts, and even discussions, because these terms come up quite often in presentations. So we'll discuss these plasma science terms in our own words first, and then we'll look at definitions of those terms. I'll have time for questions and a summary of what we'll cover today. So today, these are the 11 basic plasma science terms that I have chosen for discussion. The first one is MAFs, magnetic, magravs, PMF, principal matter, principal MAFs, principal star, transition energy, transition matter, transition MAFs, and GANs. So we'll go slowly because we need to really understand them. So these definitions of basic plasma science terms are based on Book 2 and Book 3. And these books are The Structure of Light, that's Book 2, and The Origin of the Universe, Book 3. There are some terms that we'll discuss later from the first book, The Universal Order of Creation of Matters. But please note that these terms are also used in the first book. So in your own words, to start with, please define the following terms: MAFs, and explain what the term means; magnetic, with a capital M and with a small m, and please let us know the difference in your own words; magravs and PMF. Please feel free to unmute and respond. Anyone can start. Thank you.
And just as a reminder, you can always raise your hand and I'll unmute you there or let you come in to speak. And if you're on Facebook or on YouTube, you can certainly type your response in the chat windows there, and I'll make sure to get them announced.
And if you could read whatever they respond, the responses are in the, because I won't see the chat.
Yes.
Thank you very much, Flint. This is really not a test, so there shouldn't be any hesitation. It's just
Yes.
we want to start a discussion.
Yes, go ahead, John. You type something in there. You can always unmute.
Good morning to you all. No, I was just answering Ursula's question there.
Yeah, that's also a question on the screen. Asking what PMF means, and of course PMF stands for plasmatic magnetic fields.
There are four terms displayed here. Even magnetic, there is hesitation to explain even magnetic. That silence is so loud.
Yeah.
Maybe you should tell some jokes to warm up the audience here. Get them going, Gatwa.
Yeah, well. Yeah, anyone can tell jokes.
Oh, if plasmatic.
So let's help Gatwa out here. John, you should know what maths are, or should be able to explain magraves or even the magnetic, perhaps, eh?
Yeah, I started with the simple ones.
Maps or magnetic fields would be maps is magnetic fields, and PMFs or PMAFs would be plasmatic magnetic fields.
Okay, yep. And what would magraves be?
Magnetic gravitational fields.
Okay.
Being gravitational when they attract each other and magnetic when they repel each other.
How about magnetic with capital M? John?
Yes, I'm recapping. With capital M would be the magnetic fields of the Earth, planet Earth.
Only planet Earth, or?
Well, yeah, mainly yes, but there's also the magnetic field of the Earth is due to an interaction with the magnetic fields of the Sun.
So what would the magnetic fields of the Sun be?
Pardon?
So how would you write magnetic fields of the Sun? With a small m or with a capital M?
Well, according to the definitions Mr. Keshe has given, with a capital M would be the magnetic fields of the Earth.
Well,
I thought the capital M had to do with the principal magnet, what we call the principal magnetic fields, which is different than the small m, which would be a magnetic field as in a magnet or some other physicality sort of magnetic field.
Okay.
That's what I thought, but I could be wrong because I haven't not up on that. We need to have some of the students who have been learning this recently to weigh in here, I think. Here's Jay has his hand up. Maybe if we allow him to speak, maybe he can clarify for us. He's one of the students.
And there are no wrong answers, so people should not hesitate to tell us what they think.
Good morning. No, I just had a question. I wanted to know the difference between a MAF and a PMF. To know, like a magnetic field and a plasmatic magnetic field. What are the differences?
There will be time for questions later, but that will be covered when we look at the actual definitions.
Okay, thank you.
So you should probably tell us what these terms mean first, in your own words. And that answer, you may already have the answer. You may already have the answer.
Hello, everybody. It's Nicholas.
Hello, Nicholas.
Good morning. It seems that, you know, magnetic, not knowing exactly how we were using it or Mr. Keshe was using it, would be connected to the fields. And it then has its own qualities and character. In the small m, magnetic, I think usually means attraction. So if a person is magnetic, it means that they have an attraction there, something like that. It's more of a quality of being, where M would be specifically the magnetic field, whether it's on the Earth, in a magnet, or otherwise. So just putting that out there.
Thank you very much, Nicholas. Any other definitions? Any other responses?
Well, Margrav or Margravs is the interaction and balancing of the field, magnetic and gravitational field, each of which have their own character and act and relationship to each other, always seeking a balance. So those are the fields, and then one can create devices that work with those fields together.
Thank you very much, Nicholas.
There's on YouTube, Playboy89 says Magravs is a magnetic field interaction with other magnetic field, and PMF gives a magnetic and gravitational field repulsion and attraction.
Okay, thank you.
MAFs are magnetic field strengths, strength of the magnetic field.
Okay, that's very good. I thank you very much for all your responses, but now I will actually go to the definitions, and MAFs just starts for magnetic fields. Now there is magnetic in the fields, magnetic fields. What does magnetic itself mean? When written with a capital M, magnetic refers to the plasma of magnetic fields created by a dynamic entity. For example, the magnetic field of the Earth. So the Earth has been given as an example, but it's not the only one. So they could be magnetic fields of a star or another dynamic entity. But when written with a small m, this simply means the magnetic fields as in what we observe at the end of a solid magnet as magnetic fields of the object without its interaction with the other fields. So it's magnetic, small m, when there is no interaction. We are just referring to the fields at the end of a magnet, for example. And Rick had this correct. So is this clear now? Small m and capital M. I think the confusion has disappeared now, because these can be very confusing terms. Why capital M matters and why small m matters when magnetic is written one way or the other. Okay, magraphs is magnetic and gravitational fields. And magnetic also here refers to the plasma of magnetic fields created by a dynamic entity. And the example is Earth. So because we make cores, we make rotating cores, and they are dynamic, would we describe magnetic in our dynamic cores with capital M? That's a question to, are there any answers? Flint, do you see any answers?
I'm just looking right now. Haven't seen anything recently. No, there's nothing coming through in the chats.
Nothing through the chat. What do you think, Flint?
Magnetic gravitational fields. I would say, yeah, whether it's capitalized or not is very similar to the magnetic definition.
Yeah, and when we make rotating cores, we are trying to copy
Mm-hmm.
the Earth, for example. So, and they are dynamic. If they are moving, if there's movement, then they are dynamic. And they have moved on their own. So I would suppose that we would use capital M. And I may be wrong on that.
Well, I have a question there. Well, it's not.
Go ahead, please.
Well, it's not a question if you want statements. It seems to me that the Margrave is is like an object. It's a noun, a Margrave. A Margrave field is a field that's connected to Margrave. So I don't know if that's supposed to be a Margrave field or Margrave. So if it's a Margrave and you're talking about dynamics, this doesn't necessarily mean a device that's spinning. But when these two fields interact, they create a dynamic. And within that dynamic, then we see certain qualities and actions. So this, of course, is going on all the time because the Margraves, if I understand last week, creates the plasma. When you bring those two together, you immediately get a dynamic, and that dynamic then is what we call the plasma.
That's correct, Nicholas. But Margraves, in this case, only refers to the magnetic and gravitational fields. So that's it. After the dash is further explanation.
Well, if these are dynamic, then
sure, and this is used especially when you look at the position of the Earth relative to the Sun or the Moon, why they stay where they are relative to each other, and this is through magnetic gravitational field positioning, Margraves positioning. Or when you take a magnet and three others, when you push, they move. At the point where they stop moving, and they stay in their positions relative to each other that they have positioned themselves. So magravs, positioning, magnetic gravitation, positioning. So this is just the term magravs, which stands for magnetic gravitational fields. PMF, plasmatic magnetic fields. It's a collection of near similar dynamic rays of magnetic fields strength. So what makes them plasmatic? Why are they not just magnetic fields? Anybody?
Would that mean a plasmatic field? If it's a plasma, then it's connected to both gravitational and magnetic. And so those fields would be a dynamic of what we call magnetic and gravitational. They're either in balance or they're always seeking balance.
In other words, they are interacting.
Yes.
Thank you. Any questions about those four terms?
There's a question from Jay here. He's saying, what is the difference between a dynamic entity and a normal entity?
A dynamic and a normal entity? Could you read the question again?
Yes, that's correct. What's the difference between a dynamic entity and a normal entity?
Dynamic is also normal. It's not abnormal to be dynamic. Dynamic is just there is some interaction or some movement.
Well, it would be operating by itself if it's not dynamic. Say if I'm by myself, then I'm an individual entity, an individual I, an individual self, an individual plasmic ray just floating around there on my own. And another one comes along and woohoo! And they entangle, and first thing you know, they've created a plasma. That's dynamic.
Good. Thank you very much. Any other questions? If not, we'll move to the next four.
Yes.
Well, I might say that even the individual plasma will tend to have a balance within it. I'm not sure that's true. Just like the person connected to their soul becomes dynamic, and that's operating on an individual identity in a certain way as well.
Excuse me, what have you said about the difference between a magnetic field and a plasmatic magnetic field? The plasmatic magnetic field is dynamic. That's the difference, or?
A collection of near similar dynamic rays. You know, they are moving like poles attract. Like poles do not attract, yeah? And like poles attract. So they form as a circular movement. Let me annotate here. Like that. That is a ray. Starts with a ray, yeah? Which has a direction. And then another ray. Then they may start interacting like that. And when they start interacting, they form a circular or spherical movement. And there could be others. And then what do they create here? Fields. So this now becomes a plasma. Because the interaction has been taken into consideration. Rays interacting create fields. And that's the beginning of a plasma. So they are dynamic in that they are moving. But one single ray that is not moving or it's moving alone without interacting with another, cannot be said to be dynamic. That's my understanding.
And this the magnetic field of a magnet is just a normal magnetic field.
It's when you refer to it just normal without the interaction. It does not mean that it's not capable of interacting. It's just when you refer to it as a magnetic field. I mean, not magnetic with a small m. When you, like, you know how they drew in schools, they showed us how to draw these magnets like that with an entry and an exit. So when you pick one of these without the interaction, without referring to the interaction, just refer to it as a magnetic, then that's when you use a small m without considering the interaction. It's not that it cannot interact.
Okay, thank you.
Sure, you're welcome. Because all of them, by the way, even these, when they are magnetic, in that they are outward flowing from the center towards the outer of an entity that is spherical. And then the gravitational would be moving on the other side, to the other side, towards the center. Remember, even the magnetical one has gravitational, because it's the same ray that enters here, the same field that enters here as gravitational, and then leaves as magnetical. So within, you cannot have one without the other. So it depends on which one is stronger in a particular field. So if it's entering at the entry point, it's gravitational. At the exit point, the so-called North Pole, it's magnetical. It gives. Another way of looking at it is the magnetic gives and gravitational takes. And you cannot have one without the other. I hope that is clear.
Yeah, and that's quite different than the term for magnetic, which tends to mean attraction. When it's in a field, it's both attraction and repulsion, or gravitational, which means is the input, and what you were saying, and the magnetic then is the liberating, the exit point. So that's quite different than just the quality of magnetic, because the quality of magnetic doesn't have the repulsion aspect to it.
It's when you refer to it, the field in, like at the end of a magnet. When you refer to that particular one, is when you use the small m to describe it. These are just descriptive terms, but they have meaning, of course.
I don't think you're going to get a magnet that doesn't have both positive and negative.
Have you seen one without both? I always thought if you hold a magnet one way, like place it flat on the table, and you have three other magnets, like Rick has done, if you turn it around, like the up goes to the table, you flip it, then it acts the opposite. If it were pushing, that means it were magnetical. Now it starts pulling. The other side is gravitational. It's the same piece of magnet. Rick, do you have anything to add about that? How you have both magnetical and gravitational in the same entity?
Well, I think the magnets is more or less an allegory for the actual fields, that it's not the same like we were talking about that the capital M magnetic is different than the small m magnetic. And so like, how do we explain gravity in terms of what we normally call gravity on planet Earth, and what we normally call the magnetic field of the Earth, what the scientists would measure as those things, which is a different way of looking at it than looking at it from the plasmatic point of view. So it's the way I understand it is our position on the planet, which we normally attribute to gravity. We don't think about the magnetic affecting us and so on, but our position is basically the difference between the attracting and the repelling, and whatever that difference is our position essentially. So like you're saying, each magnet will find its own position if it's in the repelling mode, and if it's in the attracting mode, it slams together and pulls together. But that's a little different than the way, in effect, it's both of them working at the same time with the maggrav, with the magnetic gravitational. Like you say, you can't have one without the other. That's what Mr. Keshe said. So on the one hand, we have, the magnetical, which you say is like repelling, and the gravitational, which is pulling. So basically, the difference between the two provides that positioning. And on planet Earth, it's different than it would be out in space in a way, because out in space, everything's more fluid, and things can position themselves much easier. We're stuck to our gravity environment here on Earth, so we don't get to experience the magnetical as much as we would out in space, where it becomes much more important and much more stronger forces. The magnetical may be much stronger than the gravitational to a cloud out in space, for example. But here it's the gravitational, everything's, heavy. It's planet Earth after all. That's why they call it Earth. It's heavy, it's grounded, it's the matter level environment here. But you could take it another, from that whole description into other levels as well, and think of it as the interrelationships of people. And we have, our attractions and repulsions, you could say, that we have as humans when we go about our life. We encounter someone else. We usually engage in that situation we're either, we feel like we're attracted or into the situation, not attracted to the person necessarily, but we feel like that interchange is okay and we're completely open to it. Or we might find something that's repulsive or repelling in the situation that keeps us away from engaging in that person. Maybe you didn't like the smell of them or the look of them or something they said or something. And all of a sudden the fields change, everything changes, and you want to head in the other direction, and you go and find another position somewhere else, maybe in a cafe or something, and find your own position according to the fields around you, which are usually in a attracting and repelling format. I'm not sure if that was all helpful or not, but that was one perspective.
Yeah, very helpful.
Yeah. And you came up with you introduced gravity, which is very interesting to actually discuss here. Gravity. And what is gravity? Anyone? How do we describe gravity? Gravity equals gravitational fields minus magnetic fields. Yeah. So this is very interesting because it tells us that gravity fields are always stronger than magnetic field because uh, everything has mass in this universe. And I believe here I'm explaining mass. Is it mass? Gravity fields minus magnetic fields equals is always a plus. So everything has mass. This also describes how you get mass. And that shows the gravitational fields are always stronger than magnetic. Does that add or confuse us? Add to our
I'd
understanding?
say, sure, that makes sense. After all, love always wins, right? That's the pulling together force, the connectedness of everything. And that's,
Right?
in a way, is the gravitational.
That's correct. And it always wins. It's always stronger because everything on in this planet has mass. So how do you get mass? Gravitational minus magnetical.
So there's a question here on YouTube. Apollo asks, so magnetic fields are created by rotating cores or otherwise movement? And what does dynamic mean and what is a plasma?
Magnetic fields are created by the interaction. Or is he asking about which magnetic fields? Initial magnetic fields?
Well, we wrote it into small m.
Well, yeah, it's a dynamic. It has to be a dynamic entity, like Earth. The fields created by a dynamic entity such as Earth. In the explanation in the book, I'm using the explanations as defined in book 2 and book 3.
And we do know that fields are created by the reactors, and some of the fields are magnetic with a small m kind of magnetic, and other fields are what could be called maggrav fields, or more to do with the principal fields rather than the magnetic that can be defined by magnets type of thing.
Yes, and when we look at these terms, the few that are displayed here, things will get a bit more clearer than they are right now. So, in your own terms, how do you define principal matter? What is principal matter? What is principal mass? Principal star and transition energy? Any of us?
Andreas had his hand up. I'm not sure if it was to do with this or something else, but I'll promote him and so he can speak, and maybe he can enlighten us. Or perhaps he had a question. Andreas?
It was from before, but I'm thinking about the new themes too.
Was that a question?
No. I had my hand up before 5 minutes
Okay.
ago.
Okay. And it stayed up. Principal matter. So if we are looking at, I really want a discussion, but it's not coming. What's happening? If you look at the way matter has been shown by Mr. Keshe, principal matter. This was dark matter. Let's say antimatter. What we used to know this as. Old science. Dark matter and matter. So how do you describe principal matter? Which one of these is principal matter and why?
Well, principal matter is the matter that the initial matter that makes everything up.
The one that makes everything up is the principal matter, yeah?
Yeah.
That's correct. And in terms of field strength, which one are the strongest in this drawing that I have here? And which ones are weakest?
The strongest is going to be principal matter, and the dark matter is your transitional matter, and then this regular matter is what we've, 3D touch and feel and see and everything. It's something that's coalesced into a lower form of energy.
That's very good. Ring magnet explains it very well. If it's ring magnet, the empty space is the one that we has very strong fields. And between the empty space and the actual ring would be the transition. So that would be principle, the empty place. This would be the transition, and then the ring itself would be the matter. You can also look at an egg with the center, which is a yolk. That would be the principle. Example, the white of an egg would be the transition, and the shell itself would be, the matter that you see. Not that the others are not matter in an egg, but this is an example. How about principal mass? We already said magnetic mass starts for magnetic fields. So principal magnetic fields is not difficult to figure out. The interesting one is principal star. What's a principal star? Any responses? And the energy here is also important. This one is the important transition energy. How do you describe energy?
The center
Go
of
ahead.
the center?
Yeah, go ahead, Brett. Sorry.
The center of the center?
Would be the what?
Principal star.
Okay. Do you have
The
another
center of the center.
another way of describing it?
If we're building a reactor, we would use dark matter in the center of the hydrogen. So it would be the principal star, the center of the center.
Okay.
I don't know. Am I right or wrong? I don't know.
What has it been known as previously, prior to plasma technology?
The core.
The what?
The core.
Or the core. Okay. All right. Thank you very much. I'll continue. Principal matter. This matter in conventional physics is called the antimatter. What I was just drawing here. And that's what is shown in this drawing, Mr. Keshe's drawing. This appears on the front cover of book 1. And that explains how matter, all the matters, the principal matter, the dark matter, which is called now transition. The principal matter used to be known as antimatter, and then matter itself. So as the real structure of this matter is now fully understood, and that is to say, is the source of all matters, from the dark matter to matter, it is now called the original matter or the principle. That is what was known as the antimatter. Now known, due to Mr. Keshe's technology of plasma science and technology, it's no longer antimatter. There can never be antimatter. That term itself does not make sense. What is not matter cannot be antimatter. So it's the original or the principal matter, or other matters come from that.
I thought that the dark matter was when everything is in perfect balance, and there then becomes a stillness or an emptiness in it. And as soon as you disturb that balance, then it's going to seek balance. And out of that then becomes the dynamic. And then that's when the matter would be developed. So the term dark matter out there that would be potentially anything, but essentially nothing. So when you look at it, you see essentially nothing. But as soon as you introduce then the dynamics, it becomes something, which is matter.
But even in that case, if you see nothing, that will not mean nothing is moving. There are things that are moving that you don't see, like fields, for example.
We have a amino acid based eyes, amino acid based Earth eyes, and that's only going to pick up a very small frequency of light. And we called it dark matter because they couldn't see anything there. And so it doesn't mean there isn't anything there. There's actually the bulk of creation is there in the dark matter or the transitional matter. And it's not a state of stillness, it's a state of flux. It's always dynamic, moving, constantly moving. It's in transition as it acts, interacts, reacts, and dynamically forms different entities.
Thank you very much, Flint. So any other questions? Is this clear now? The original matter, where did the original matter come from?
Can I ask a question, please?
Go ahead, please. Jalal?
This is basic plasma science. How you apply it to a human body in this three section: matter, antimatter, and dark matter? How you apply it to human body? Because we are definitely we are plasma.
So I gave an example like an egg, where the yolk has the strongest fields. The white would be the transition between the yolk and the shell. So the outer covering would be that's where the fields have a boundary, and that would be the shell of an egg.
Okay, that's very beautiful and perfect. But how we apply it to a human body, let's say.
Well, wouldn't the principal matter in a human body be the I am, the pure self?
Your soul?
Yeah, your soul.
Principal matter in a human body would be the soul, and the matter would be the body, what you see.
In the transitional matter is your emotions.
Matter would be the emotion.
Yeah.
Can we say in a human body there is physicality and there is emotion? The interaction between them creates the soul.
The interaction between the emotion and physicality creates what?
Soul.
It's the other way around. No, the soul creates physicality.
And then the interaction between
The interaction between physicality and the soul would be the emotion.
in a plasma ray, you have magnetical and gravitational. You don't have third. The third is the interaction between the two. So if I say the gravitational is the body, the magnetical is the emotion, the interaction between them makes the soul. The interaction between everything is this is the important thing. Yes, we already know that, because one ray, it must interact with another one.
No, one ray can
create.
interact. One ray
Yeah.
can interact with itself.
Yes, but it will not produce anything. It will interact with itself. Yes, and in this position, he will make the gravitational and the magnetical. Depends of his strength, but interaction between two plasmas. If you remember the teaching of Mr. Keshe, first you have one ray of plasma. Two rays or more of plasma makes physics.
Makes the plasma, you mean?
Yeah,
Oh.
Makes the
because
plasma.
He did mention, like Flint just mentioned, that it could be one ray. It doesn't have to be two. We started out with two in our original plasma animation. That's what we kind of thought it was. But he mentioned later that it could be just one ray, and it's the image of the snake eating its tail. It basically turns into a plasma that way.
Yes, when it is elongated, the weak is the end, and the strong is the front, and the front gives in the plasma, the strong gives to the weak, so it will like
way to look at it. Yeah,
but this one will not create anything, because it is interaction with itself only. It's the same thing. If you have a body of a man, he have physicality and he have emotion. When he cannot produce anything. Only when he is interacting with another plasma, a woman or a man or any entity, and then there is interaction between the fields.
Yes, but is there anywhere in the universe where there's not fields? So we're always interacting, and they're always interacting in some way or another.
Yes,
we're
absolutely.
Always, so there's no such things. We're seeing right now this single plasma, but we forget that it's part of a bigger plasma environment. Every plasma is enclosed by another plasma. In effect, we may not see that plasma. Like we're in the plasma of the sun within our solar system, and we don't really notice that as much as because we're on Earth inside of the plasma of our atmosphere and of Earth and so on, protected from the other stronger fields that are actually around us.
Yes, but if you understand one plasma, you will understand the whole. That is what Mr. Keshe is saying. That is the point here.
Yes, Jalal, we agree. But one ray, one single ray. Life began with one single ray, which had an image of itself and interacted with that image of itself and created fields and a plasma.
Yes, but one single ray, it came from the magnetic. In the long distance, when it's awake, because it's elongated, and then this happens here from magnetic alone, and then come magnetical and gravitational magnetic positioning for this plasma, because the strong gives to the weak, and then you have one plasma with gravitational and magnetical field. When it is turned to itself, but let's say in the beginning, the first second when this ray come out from its original plasma. It is more magnetical than gravitational.
That's a very good statement. It's more magnetical than gravitational, but that means they are both. It has both.
Yes, it's the same thing. A human being, it have physicality, and the same thing, it have emotion. Only when it's a strengthening, and then if you are more gravitational, you are more taker, or you are more giver. More giver, that means you are working with the emotion. The let's say the soul of the emotion and the soul of the physicality.
And Weatherall, do you have a question there? You can go ahead and unmute.
Thank you. Yes, I do, but it's not on the current topic, so I was going to wait to ask it.
Okay.
So Jalal, would you continue and make your point? I'm getting lost.
Look.
Well, what I'm getting from you, Jalal, let me just try to summarize what I think you're trying to say, which is basically in one line, it takes two to tango. In other words, just one plasma sort of off on its own, there's no interaction. So we have to have more than one in order to have that, maybe to create that free plasma in between, for example.
Yes.
Is that what you're talking about?
Yes. That's why Mr. Keshe always saying it need two or more with all the things. Maybe this is only here.
They say that in the Bible too. Now that you've said that 3 times in a row, it takes 2 or more gathered in my name, right? That's the takes 2 to tango idea again there.
Do you remember Mr. Keshe? He said, you give, but if there is no one to take, then you are not giving anywhere.
Yeah, that's what creates the flow, actually, is you have to have the taker in order to take what you're giving. And that's the way the reactors worked. In fact, that's how they got up. That's how Mr. Keshe got up to the famous 129 Tesla, was that there was a taker reactor and his giver combination. And it's like, it's sort of the equivalent if you ground out a connection in your household current, it produces a really big spark. But until there's that grounding, there's no effect happening. There's nothing happening from your plug-in outlet on your wall, for example, until you actually stick something into it and cause a bunch of sparks to fly by grounding something in it. So it's that grounding that creates that current flow, you could say. It may not be current in terms of electrons, but a current flow, a gradient that gets the whole thing going. And that's part of the environment and conditions to make it work. Otherwise, like you say, there's no, it's like trying to play tug of war with just yourself. It's kind of, you got a piece of rope, you got yourself, and you're just like, come on, guys, I need some help here.
Exactly. There's no confirmation for existence.
Yes, right.
So only Dr. Gatwa, what I'm saying, because I am not well educated. I brought this example as because you must see your body first. You must see inside you, and then you will know the universe, because we are all one. It's the same thing. What's happened in the atom and what's happened in the universe. It's exactly the same thing, but this one is in a bigger scale. And for the universe and the unicos, it's like the atom and universe. It's the same thing. It's all in one system, plasma system. It's need two to interact. And thank you.
How about the idea of the last man standing? Jalal, Mr. Keshe has talked about that many times.
You forget something. You forget something I told you about. I said the physicality and the emotion. The soul of physicality, and this is the heart, and soul of the emotion, and that is the love. When they interact, they create soul. Look, it is a spiral. It is a snake. There is no beginning and there is no end. You came from the soul and you create soul.
Which soul do you create? Man is not the creator of his own soul.
No, there is Mr. Cash said, now you will not comprehend. You will not understand. But I put it for you that the first is the plasma. But there is one step before, and that is you will not understand it now until you are really comprehend the plasma and the work, and you work with the plasma, not in the matter state. But one thing in his teaching I noticed, because you have gravitational and magnetical, and that's mean the same thing. You have physicality and you have emotion. So there is everywhere in this spiral, there is physicality and there is emotion in every section, in every level. And sort of, because if let's say you have 0 and you have 1 and you have minus 1. Let's say minus 1 is gravitational and 1 is magnetical for this position, but 1 for 2 it is gravitational and 2 is more is magnetical. So which one is magnetical, which one is gravitational? So actually here, to understand, there is magnetical and gravitational. But when you understand it right, and when you comprehend what is the work of it, it's like same your body. It's exactly the same. Because if you go to the physicality, you are gravitational. If you go to the emotion, if you feed from the emotion, you are magnetical. Because this is high source of plasma. But both of them is there. You cannot see it. Dark matter, as Flint said, and you cannot see it because its residence in different frequency or different position. That's all.
So how would you describe dark matter in human body?
I've got a way that might describe it in a way. I was just thinking about this. I've got a video that I can show that I made up that's based on the same one that we just saw of the plasma fields, but I changed it a little bit. So let me just share the screen and let me try that, see how it works to try to get a better handle on this, because I think it has to do with the idea of what's in between the plasmas is important. The interaction between, like Jalal is saying, basically about relationships and you know, what's the physicality, and then we have the emotion. Well, the emotion is like what's in between the plasma fields, you could say. So let me just share here, and I'll play it through. And it's got a little intro that looks like Keshe Foundation, but okay, here we go. I think something happened there. Here we go. So it starts off like the other video. We have our plasma. here's the difference. So that can become, say, a proton or an atom in our bodies even. But here's what happens. We have the second field, like you're talking about, Jalal. And these fields find their positioning, their magnetical, gravitational positioning. Each atom in our body finds its position. But there is a gap between all of these atoms, all of these plasmas, or cells, you could say. And that's what's the free plasma is actually what's in between all of the plasmas. And to us, our body looks solid, but it's actually a whole bunch of plasmas put together, and the ganses and plasmas. And it's the gap that's so important with the nanomaterials and with the uses of the ganses and other things as well. So of course, the gap is important in space because we have to have the right gap between the Earth and the sun. Otherwise, too close is not good, and too far away is not so hot either, literally. Okay, that was my little video. Anyway, I thought that might help because I think that the what we call the darkness is just what we can't see in between the plasmas.
Thank you very much, Rick, for sharing that.
Yes, thank you, Rick.
Does that answer your? Does that help explain what you are saying, or muddy it up? Jalal? Did he disappear?
No, he's still here.
Okay.
He may not be able to speak right now. Sometimes it's noisy where he's at.
Ed asked, saying there are beings that exist without a physical body. Does this mean that there is no emotion present?
I don't think that's necessarily the case. Otherwise, the hanging plasmas would have no emotions. They are beings between us and the sun.
What is emotion? Do you have a definition of that, Gatwa?
Emotion?
While we're on definitions today, it might be good to, because I was just thinking of that myself. Is emotion, is it a field or is it a feeling? Do we have to have a physicality to feel an emotion, but maybe the emotion itself is not of the physicality?
Actually, we create the emotion. And, we create the emotion. That's how we create diseases. So, or is it already there? We just use it to create something that's either helpful or not helpful. Because in one of the Mr. Keshe's explanations, where this is the brain and the soul, so that's the soul part, and then the emotion is between the soul and physicality. And he explains that this emotion is, you can divide it into two. The part that is closer to the soul and the part that is closer to physicality, which we actually know how to use very much because we create some emotion. We are sad. When we are sad, we create that sadness and it comes out as tears. So we create tears. And we can use the same part of emotion, this part, to create tears of joy or tears of sadness. So you can have both.
Are you reading my mind, Gatwa?
Let me explain and then tell us about your mind.
No, you are explaining everything.
Okay. And then now here, you can also use the same emotion. We use the emotion here. Let me color it differently. this part of the emotion to feel pain. If something happens, we can feel pain on any part of our body. That means we have used the emotion that is closer to physicality. Now, in order to extend our lives, for example, which is possible, this plasma science, nothing is impossible. So if we wanted to extend our lives to live for 2,000 years, for example, then this is what we need to concentrate on. This part of the emotion, then if this emotion, we already know how to create tears and to create pain, then this emotion would determine what we wanted. This is closer to the soul, because soul is the creator of physicality. Then we can use the soul through this emotion to extend our lives, for example, or to get taller. If we wanted to be taller by 2 inches, for example, we can do that. If we wanted to change color like chameleons do in different environments, we can do that. All we need to do is become experts in talking to our souls, find our souls, and use the emotion closer to our souls to create the physicalities that we need. Jalal?
Yes, Gatwa.
Go ahead. Now tell us about your mind.
No. This one I came across yesterday in the teaching, and I said, "Wow, why we didn't we focus on that?" And today, when I speak, really, I want in the end to go to this chapter here. This is the most important chapter to understand, really. If you want to understand the plasma, you look to yourself. But if you want to understand what can you do with the plasma, look to what just now you speak about, the tears. Emotion converted to matter. Guys, this is the important thing. This is the most important teaching. After you know about plasma. And this is what Mr. Kashi's teach us all the time. How you create your own spacecraft. How you can create your own materials. How you extend your aura. Everything in this small drop of tear. We need to speak about it much more. And now there is so much will be started here working. Sorry, Gatwa.
Thank you very much for bringing this up. This is actually covered in the 200th, I believe 200th Knowledge Seekers Workshop. So you can go back and watch this. It's explained very, very clearly how we can do whatever we want, how we can create the physicality we need, how we can extend our lives to live for eons. So any questions or comments about what I just explained here? Or any questions to Jalal?
Hello, Gata. Hello all together. This is Klaus Dieter.
Yes, but
from my side, emotions is energy in movement. And the movement comes from the consciousness. The consciousness brings or sucks this energy in movement, this emotion to us. And every time we chose which side from the filter, as you mean, from the filter, more the side from the soul or more the side from the physicality. So we became the energy on this or on that side. And what we can choose is which side the filter, with which side from the filter we act. And so we become more and more a better feeling how to bring in the energy in this state, what we want or what we chose. That's from my side.
So, Klaus, you said energy in movement equals, then what is energy?
What is energy? Energy is, you can also say the plasma or chi or prana, all this kind is the same. Is the rough state of what all is around us, and the consciousness brings in a special form with this movement from the energy. We call them emotion.
Okay. Thank you very much. Klaus, yeah?
Yeah.
Any questions or comments?
There was a question in Facebook here. What is unconsciousness?
Did we talk of consciousness here, or I didn't bring that up? I want to stick to my notes here, because unless something comes up that that is related, I like to stick to the definitions that I came up with. But anyone can respond to that. Consciousness is awareness. So the
Yes.
opposite, if there is no self-awareness, then there is no consciousness. That's how I would describe that.
I have an experiment for Jalal, if you'd like to do it, is to create exactly what you're saying. If you get two people and you put two chairs back to back, and each people have a photo of each other, and this is exactly what we're talking about is the principal matter. If you have one person look at a photo and think about good things about the other, and the other doesn't look at the photo, then when they start to feel something from the other, they look at the photo of the other and then think about good things about the other. So what you have is exactly what was shown about the principal matter. You have one person gives to the other, and then the other gives to the other, which feeds the other, which feeds the other, which feeds the other. And what you'll find is that you have two people that feed upon each other in the giving. So remember that we don't want to take, we want to give. So if one person starts the giving process and then the other person starts the giving process, then the other person's giving the process and the other person's giving the process, you get an interaction between the two people, and Jalal, you'll find that what you get is both the people going, I can't handle it anymore. It's too much. So try the experiment. I've tried it and I found that it's absolutely mind-blowing. So two people back to back, both have a photo of each other. One turns the photo down, the other thinks of the person. You're in the same field because you're back to back. You can try it forward to forward as well, I suppose, but I did it back to back. And because they can't see each other, and they just think of the other person in a positive way, and that then gives to one. If one then turns the photo up and gives to the other, the process starts. So just an interesting experiment, just to think about. So much love, guys.
Thank you very much, Brett. Also, Jalal mentioned that when you give, if nobody is available to take, Did you mean, Jalal, that whatever you give is lost? I believe Mr. Keshe has said about banking. So when you give to the source, it's banked there. So others that may need later, you take from the source. So there is really no wastage. You cannot stop giving because people are not taking, or you think it will not be taken.
No,
Just give.
what I meant that if there is no one take from you, this what you give, it will be set. There is no one to nowhere to deposit because it is stationary. There is no interaction.
Some entity will need it in the future, and it will be available. It's like sunshine, for example. You wake up in the morning and go outside. When you were indoors,
this is where you put it between the two interaction, physicality and the emotion, and this is you put it in the soul, your soul.
Yes, your soul is your son.
Yes. The question here about conscious and not conscious. We need to know there is physicality, and there is soul of physicality, and there is emotion, and there is soul of emotion. The soul of physicality is the heart.
It's controlled by the heart, not the heart. The soul of physicality is in every cell, which is controlled through the heart.
Yes, but this is the soul of physicality.
That's correct. Not the heart. It's the controller of the soul of physicality.
Yes.
It's like the headquarters.
Let's say the storage of these souls, the controller, the guidance, the highest, let's say the highest in this matter. Conscious that this particularly part who is working in physicality, who is adjusting everything, who is working everything. Without emotion, there is different thing, because there is no magnetical in this way, only gravitational, and this will not happen. But sometimes there is physicality and there is emotion, but there is no soul of emotion. Soul of emotion, and this is what what Mr. Keshe speak about. The highest is love. If there is no love in this situation, what will happen there? There is no giving.
Jalal, if even rocks have souls, why wouldn't emotion have a soul?
Emotion have a soul, and the soul of it. Look, what the meaning of soul? What the meaning of soul? Soul for this matter state is the heart, because it's working in the highest, because he's the giver for the physicality. The soul of emotion, who is the giver? The best giver in emotion, love. So these two interaction between them two, who is what creating life? Who created you, Gatwa? From where you came? You came from interaction of physicality and emotion. Which one make a space to the soul to come in? That means they make place for the soul. And that's why you, in the beginning of your life, the controller of your life for the first 7 years is your soul, giving the instruction to the emotion to care about the body. But the distance between the emotion and the soul, with the time, because the physicality, it has so much destruction, this has so much troubles, it come down near to the physicality. the part between the soul and the emotion, there will be a much distance. There is a gap, so much gap. The interaction between them, it will be less and less and less until you are just like another human being. Just only physicality and emotion. There is no soul in it. There is a soul in above, but there is no connection. The connection is very weak. Sometimes in your dream, you get connection.
Thank you very much, Jalal. Any questions or comments for Jalal?
I would like to say something to the painting or the graphic on the picture on the side with matter, antimatter, and the dark matter.
Sure, go ahead, please.
And I read in the second Keshe video out of what exists the neutron. And there we have matter, antimatter, and dark matter. And there are three magnetic rays which are called the F1 point, or the black holes, which are trapped between the matter, antimatter, and dark matter, and they don't have the same field strength and cannot bind themselves to one of these three kinds of matters, but they are influencing the speed of the rotation of the matters. And what is if the F1 field is the emotion field, which gets not really a direct connection to the matter, but it influences the interactions of these matters, and so it influences the matter itself too, because matter is not only matter, it's antimatter, dark matter, and matter. It's the interaction of these three things. Do you know my link, what I want to make from the emotions to the physical point?
Thank you very much. But these are old terms. The actual terms now with the plasma science is, instead of antimatter, that would be the principal matter. Instead of dark matter, it's the transition matter. And then matter remains the same, solid, liquid, and gas.
Yeah, my question is, if the emotions are the star in the middle of the picture between matter, antimatter, and dark matter, the white point, that
the residual, because of interaction. When two things interact, usually there are residuals. So those are residuals that move between those three. The residuals would be like when there is friction between two entities, like plasmatic magnetic fields of the sun and the plasmatic magnetic fields of the earth, where they meet. At that point, there is friction, and the first thing to be created is light out of that friction. So here we are looking at the center, the so-called, you said F1, would be the residuals, because there is friction in these movements. Is that clear? Did I answer your question?
Yes, I'm reading and I don't come to the link. I just wanted to say, you described it in your words, but when that is the emotion and that are free magnetic or free magnetic rays which are influencing the three matters, then that could be the emotion. Sorry,
what you see, the arrows you see is the movement. The arrows you see is the movement, the transition. Energy in transition that moves from principal matter to matter through the dark matter. You know the dark matter moves from principal to matter? And that may become clear in the next 2 slides.
Okay, thank you.
Oh, you're welcome. So this matter thing is understood now, and the principal matter is the source or the original matter, the source of all other matters. So I'll continue here. And that's the structure in a better picture of the structure that shows principal matter, previously known as antimatter, transition matter, previously known as dark matter, and then matter itself. And of course, there are residuals at the center. So let's go to principal mass. These are magnetic fields which are in the principal strength levels and are considered to be in orders of magnitude, several hundreds of times stronger than the magnetic fields which make up the tangible and visible matters. You see, the magnetic fields that make up the visible matters are very weak in terms of field strength. So principal magnetic fields are by orders of magnitude stronger than those that make matters. Is this clear, or do we need any other explanation, or are there any questions? So not all fields are equal. Some are more equal than others. The principal magnetic fields are way stronger by orders of magnitude. And Mr. Keshe has a picture here, a figure that shows principal maps of the universe, how they separate, the unwinding of magraves in an entity. Principal magnetic fields. So now we come to the principal star. And this entity in the conventional physics is called the black hole. Who knows the description of a black hole? What's a black hole? What is now known as black hole? Which Mr. Keshe calls principal star.
Dr. Gutterwell, this is Dimitri, is a
Yes,
black hole, is it a very, very strong gravitational field strength?
Okay, is that what makes it black? Or is that what makes it a hole?
Well, conventional science might say that it's a black hole because it doesn't allow the light to exit because the gravity is so strong that it actually won't allow light to exit the black hole.
Thank you, Rick. Actually, let me bring up the definition from Wikipedia. Astronomical object so densely massive that anything falling into it, including light, cannot escape its gravity. So if it cannot escape its gravity, what does that mean? Where does the light go?
Mr. Keshe teaches that when something is dark or black, it's in balance so that the light is not created. It's not that it can't escape, it's just in balance.
When you do nano coating, why does the copper wire or copper, whatever it is, piece of metal, why does it turn black?
I think it turns black because it absorbs all the fields of the light.
Not of the light, but of magnetic gravitational fields. It absorbs.
And why it's absorbed, Dimitri? Sorry, Gatwa. Why it's absorbed?
Okay, let me draw that. Let me annotate.
This is a question for Dimitri. You need to understand why it's absorbed, the lights.
When you nanocoat.
Why does it absorb the light?
Yeah.
It absorbs the light because maybe the gravitational fields are more predominant than the magnetic fields. We know that the magnetic fields originate from the gravitational fields.
Look what Gatwa is drawing. Look what Gatwa is drawing.
I'm gonna need to go to my computer. I'm on my phone.
Okay.
What happens here is that the copper is like popcorn, you know, it pops. So, and layers, multiple layers, up to between 20,000 to 50,000 layers of individual nano coppers. Nano, in this case, means individuality, and small in scale. Nano traditionally means 1 billionth of a meter. But in the explanation that Mr. Keshe gives, he emphasizes that it's like if you have, for example, guns of CO2, CO2 is usually written like that, but in a plasmatic way of writing CO2, you can write it as, of course, this is heavier oxygen, so OOC. So 2 oxygens and 1 C. Now, their molecules, they kind of stay together. You have seen boards drawn of how these things stay together, molecular boards. But in plasmatic form, they are not really attached. They can be together because of affinity. They like each other's company. But that doesn't mean that they are not dynamic. And that dynamism means that this O could find that this O is where this O's position is better place for it in terms of near similar field strength. So this could move there, and of course this now may take that position. So there is dynamism, there is movement. They are moving here. And now when they move, they create, because they are spaced, the one that pops latest finds space through Margrave positioning. So it finds, they accommodate, these layers accommodate, or these nanomaterial accommodate others in terms of field strength. Those that are similar in field strength may stay closer to each other. Now, what is very interesting in nanocoating is that now things are not allowed to come in this way. It creates, that's why it's a super insulator. Super insulator. We will no longer need insulating materials for copper wires or electricity when we do nanocoating properly. But at the same time, this becomes a super highway where you can store information or energy. Because between these spaced nanomaterials, there are spaces which now act as pockets for information and energy. So why is it black? Why does it turn black? Because it has absorbed the full spectrum of magnetic gravitational fields. Full spectrum. A good example here would be a plant leaf. Plants are usually green, which means they have absorbed, this is old science, how it's explained, is they absorb the full spectrum of rainbow colors, you see, except green. They absorb all the colors of the rainbow except green, so they appear to be green, which means if they absorb green too, they would be black. If they absorb the whole spectrum. So does that explain the black hole, why it's black? I just wanted to explain about nano coating because somebody asked about why it turns black. And said it absorbs. What did you say, Dimitri?
Sorry,
anyway, black.
I said it absorbs the light. That's why it's black, and that's pretty much what you've just explained there. The gaps between the nano coating, the atoms that are released but kept on the surface, creating the nano coating. Those gaps between them are that's where the plasmatic energy is stored. So all the fields coming in from the surrounding environment are collected and stored in the gaps between those nanoparticles. Light being a field strength is why it's black, because all the colors are absorbed.
Yeah, instead of absorbing light, I would explain it as absorbing the full spectrum of gravitational magnetic fields. I think there is a video that shows that explains what that means, why they are black. In any case, black hole has been defined as astronomical object. Astronomical here comes from astral, so stars. As it doesn't come from how big. So astronomical object so densely massive that everything falling into it, including light, cannot escape its gravity. But what does Mr. Keshe say about that? He calls it a principal star, and he says in reality, in the center of what is called a black hole in the universe, there exists and is the home of the principal magnetic fields, matters, and principal matter. Therefore, the black holes should be called the principal stars in the center of galaxies, stars, plasma of protons, and other entities like this. And this is explained in book 3 on page 126. The pages may differ depending on which edition of book 3 you have. So there is really no such thing as black hole. Is that lack of understanding of scientists made them call it a black hole. In the center of the so-called... Yes, please.
Oh, sorry, go on. I just wanted to ask you, would you say that the principal star in the human physicality is the soul?
Yes. I would say that, yes. Or part of the soul, the center of the soul.
Yeah. Center of the soul is nice. Thank you.
You're welcome, Dimitri. Any questions?
A black hole is the same thing like a wormhole, or?
If the smaller, and you know, the hole is a void, looks like a void, yeah? Like a hole. It must have a center which has stronger fields than its periphery. Or what do you think?
Because he describes loosened magnetic fields in a plasma as the F1 field, and he says that in the normal sciences it's called a wormhole or torus field. Is that the same like the black hole, which are you describing because it's in the center of the solar system?
Where are you reading the materials from? I don't have access to
from the Keshe 2 video, the explanation of a neutron.
Oh, yeah, that is that I don't have that in this presentation, so I can't comment on that because I don't know.
Yeah,
I haven't.
it's totally interesting for me because I have it in front of me and there are so many links to that. And that would mean that the black hole.
Do you want to show it? How do you want to share it? Can you share what you?
I have it printed and in German, so it would be not good now.
Which video is it from? There's 5 videos of the original. Is that what you mean? One of those?
The second one, out of what exists a neutron, and it's like I don't have the minute.
Okay, just a second.
By 4 minutes.
4 minutes. Okay, let me. If we want to, we can bring that up, Gatua. It's we can just go right to the new KFSSI website. Actually, I think it's on there. Let's see if we can look at it that way. Just a second here. And let me share.
Out of that explanation, a black hole should be free magnetic rays, which are not similar to others, to be able to interact, and that's why the hole is black, because it does not interact with the fields of the sun. So there is no friction, and that's why it's black.
Okay, so just do it this way first. Okay, so this is the new KFSSI website, which I recommend everybody check out. It's pretty cool to start with, and it's easy to navigate. And we have, what is plasma at the top there, and you can go through each of these categories and whatnot to get to different things. And somewhere here is the videos from those initial Mr. Keshe videos, and I'm not clear on where it is, whether it's under the public teachings or learn more. Let's have a quick look through here. I'll go to learn more, and there's a video, Mr. Keshe there. There's the Understanding Plasma Science series, 3 of them at least. And the Kids Knowledge Seekers workshops. Let me see. I think it must be back on the, maybe it's in the public teachings. I'm pretty sure it's here somewhere. No, it's not that one either. Maybe it's under What is Plasma?
Perhaps Jimmy can tell us where it is.
There, okay, under What is Plasma, which is the first category in the, when you click on here, and you see What is Plasma is 01 at the top. If you were to click on that, it says What is Plasma? Plasma science, the science of magnetical and gravitational fields, a breakthrough in understanding of how everything in the universe works. You click on the Find Out More there, and it takes us to plasma science, the science of the universe. And if we scroll down, we see the video that we've seen previous today. And here we have the 5 videos of Mr. Keshe, the 5 original videos. First one is Intro and Gravity. There he's sitting in front of the fireplace talking about the end of burning. It's time for mankind to stop the burning. And here's the second one, Matters of the Neutron. And you said it was 4 minutes and something into it. Is that what we're looking for?
Yeah, you can do it from 2 minutes too, or from the beginning, because it's about the principal matter and then going forward.
It's what, about 3 or 4 minutes altogether then? About half of the video?
Because it says a few important things about the antimatter, principal matter. 2
Okay,
minutes.
well, let's
I think
play through from the
whole piece because it's only 9 minutes long.
You want to play the whole thing? Is that what you're saying?
Let's see. Yes, please.
Yeah.
Okay, sure, we can do that. Let me just optimize things here for video. And get the sound to operate. I think that'll do it. And I'll have to turn it up a bit here. All right, let's give it a go here.
In this part of explanation of the technology, we looked at this as the planet Earth and its magnetic fields. Let us consider the same thing as a plasma in the center of a hydrogen atom, a proton. Before a proton, there is always a neutron, because by law of physics, there cannot be a position when there is a proton and no electron. So, for the first time, we call the decay of initial fundamental plasma, neutron, that is splits into electron and proton. So the decay of the plasma into neutron and proton brings into play totally different game, totally different understanding in the world of physics. What it is, let's consider the initial plasma. As an initial plasma, as we explained before, there is a matter which we see, we tangibly feel it. So our part of the matter is very simple. We see as matter. As we explained just previously, for it to be tangible, it has to possess magnetic field and it has to possess gravitational fields. So that's the three fields which we're looking for. But that's only the tangible side of the matter, of the plasma. As we know in the recent past, the plasma possesses antimatter. We call this antimatter. We showed with a stronger, much pronounced magnets. The reason being is that up to the present time, it's a belief by a number of nuclear physicists and theoretical physicists that when the matter and the antimatter come together, the matter, there is nothing left. Some charges we see, and then because they are balanced with each other, the balanced charges, the material disappears. This is against the law of physics. This is against anything we know in the world of physics. There is no chance that two real matters can come together, and then when they interact and come together, there is nothing left. So we have found out, we have developed technology, we have theoretically and scientifically proven that actually the antimatter is like the sun in the plasma condition. It's the center of the energy, is the possessor of the main energy, magnetic field of the matter. That's why at the present, some institutes, they have separated the antimatter, and within a spoonful of this antimatter, they can launch several shuttles, the energy possessed by it, into space. And in the world of physics, we have never came to understand what the antimatter is. For the first time, again you explain, antimatter is the sun of the plasma, it's the center of the plasma. The matter part we see is the tangible part, is the weakest part. But at the same time, in the structure of the matter, there is a fundamental point of the plasma, that is the matter, the plasma possesses dark matter too. Which means we have within the plasma its main constituent, which is antimatter, the matter, and the dark matter. And because the way this material is produced, this plasma is produced, each one has its own magnetosphere condition, each one has its gravitational condition, each one has its own magnetic field condition, each one has its own mass. So in fact, mass of a plasma is collection of the masses of the matter, antimatter and dark matter. And in reality, the way the plasma comes to be made in the universe, when they come together, they attract other magnetic fields which are loose within the environment. Those loose magnetic fields, which are not similar in strength, they tend to be dynamically rotating within the center of the plasma. We call this one F1. We call it this a torus field. In the dream physics, they call it the wormhole. This is actually a magnetic field because it does not have any other matching fields within it to create its own mass, to create its own gravitational field. These loose magnetic fields rotate within the center. And at the same time, there are some other fields which are not actually part of the matter because they are loose, they don't match in any shape or form. So what happened in reality, they are just loose fields within the plasma. What happened, these plasmas, like the plasma of the antimatter, when it comes close to the torus field, it gains acceleration, it gains energy from it because it's a dynamic. The same happens with the antimatter, and the same happens with the matter component of the plasma. In the book, we explained what the dark matter is and what dark matters are and how dark matters are created. In a very simple way, we explain dark matter is actually a matter where its magnetic fields are literally in balance with the magnetic field environment of the plasma. So, as the strength of the magnetic fields are the same, they don't create any light in the interaction with each other. We explain the creation of light further on, then it will become much clearer what it means. So, in fact, if we change the condition of the plasma or the environment of the plasma, we'll find the dark matter becomes visible matter because only the magnetic field, the strength of the plasma has changed. In the world of physics, they call appearance of the matter out of nothing virtual particles. There is no virtuality, it's actually matter, but because its magnetic field or its magnetosphere is in balance in magnetic field strength with the environment of the plasma, the matter does not create any light. That's why it appears as dark. So in reality, what we have, this is the structure of what we call initial fundamental plasma. It's called the neutron, and that's what the structure of the plasma is. That's why suddenly scientists see amazing antimatter. Antimatter, there's nothing anti about it. In fact, it's the most fundamental matter part of the plasma. And when you say matter collides or gets absorbed or come into touch with antimatter, nothing left, this is a fallacy. It's like saying the earth hits the sun and there is nothing left of the sun and the earth. There is no such a thing. What is left, the matter gets absorbed into the antimatter magnetic field strength. There are still different strengths. And what you see, the light which comes out, is like when the earth hits the surface of the sun, it gets some splash of radiation. And that's what it is. And that's because the magnetosphere, magnetic field of the earth, matter, comes in touch with the magnetosphere of the antimatter, and when two plasmas come together, the field interaction creates what we know as light. Different wavelength. So for the first time we explain, you do not need, and at the same time in the further talk we'll explain that the light is created in the universe out of when the two fields come too close to each other, when the magnetic fields of them interact, some magnetic fields are released in the wavelength of the light. So we'll explain that in the future, in the very soon chapters. That's what it is. This we call the structure of initial fundamental plasma. Some people call it neutrons. But when this neutron decays, I call it a decay because it's a natural fundamental decay, like uranium, plutonium, and everything else when they decay, any other material, plasma of neutron decays, and the outcome of the decay is plasma of the proton. And for the first time we introduce the plasma of a neutron, electron. And that is a very fundamental, and that's a major breakthrough to understand the structure of the proton. We'll speak about the decay in the following chapter.
Okay, that's it on that excerpt.
Thank you very much, Rick. And what was the gentleman's name that brought us here?
Andreas.
Thank you very much. What's the name again?
Andreas.
Thank you. Thank you. Now, can you explain? We have all seen. Do you have any explanation of what, remind us what you are saying?
Yes, he
The
said
F1?
that the F1
Yes.
core is the like a wormhole. That's why I ask if a wormhole is the same as a black hole, or?
Oh, maybe it is because it's right in the center.
And so
no, I think he said it's different in the video there. Didn't you just say that?
What did he say it was? He said it's a torus.
Yes, and in the normal sciences, it's called a wormhole.
Wormhole, yeah.
And this is the F1 thing is a collection, or not a collection, it is a collection of free magnetic rays which have no similar field strength to be in interaction to the antimatter or the normal matter. And without this interaction, it's just black.
We can't hear you now.
Yeah, it's difficult for me to describe that. An idea for me was that are we that F1 field, because that free magnetic rays, which is maybe the emotion, influences all matters to interact with each other. So the soul.
I don't think that would be the emotion. That would look to me like the soul.
Yeah, the soul. Let's say the soul. Yeah.
Yeah, that in the center would be the soul of the neutron. But it's worthwhile going back and listening again slowly to the explanations that Mr. Keshe gives.
Okay.
But thank you very much for bringing that up. So we learned something.
I absolutely agree with you, Gachua, that it's really good for people to go back through those initial 5 videos of Mr. Keshe. That's what actually got me hooked into the Keshe Foundation many years ago. And I transcribed those videos. So I got to know every single word of Mr. Keshe in those videos, because I wasn't very fast in transcribing. So I had to listen to each phrase over and over and over 10 or 15 times to get it to type out properly. And I did that originally so I could understand what he was saying and actually read it and look at it. And so people now, they can select the subscripts or captions in those videos at the Keshe Foundation YouTube site. And then you can actually read what Mr. Keshe is saying at the same time. I should have actually gone to the YouTube site probably for that video, and then I could select the closed captions for it. And it makes quite a difference in the understanding to be able to actually read it word by word is from what he's saying.
Thank you very much, Rick. Yeah, we need to go back and see those again and study them, repeat many times. Like Rick says he listened to those for about 15 times to really grasp this the information, because it looks so easy, but I mean, it's not really complicated when he explains it.
And also, Mr. Keshe talks on many levels. So sometimes you get it on one level and you think he's talking about, you know, the stars in space and the way things operate in space, but he could actually be talking about the atom and the way things operate on the atomic level or the plasma level, or, you know, these different ways. Like when what we just saw there, where he's describing all these parts of the plasma, it's because he's just freshly been experimenting with his reactors that are actually very active with a strong, powerful plasma inside, as he discussed in the, I believe it's the 26 One Nation, One Planet, One Race for World Peace last week. You know, he is working with what we call working reactors, and not just with GANSs, but with combinations of gases that were opening the plasma and creating very strong fields and effects. And so when he's talking about these principal energies, he knows what he's talking about, and he's actually describing the reactor when he's describing these things on his little blackboard there. So it depends on what level that you're looking at it or understanding it from. He could also be describing the way cells work in the body, as far as the same principles apply, because they're all really basic principles.
Yes, Rick, I agree. He could also be talking about our souls.
Right. So every time you go back through and listen to it, there's a possibility that you can listen to it with new ears, you could say, or trying to gain a new understanding each time, or try to approach it from a different perspective. And it should apply equally on any level you want to take it to, basically.
Thank you very much for sharing, Rick.
Thank you.
So it's not dark matter, it's not black hole, it's principal star, right in the center of universes. There exists and is the home of the principal magnetic fields, matters, and principal matter. So black holes should be called principal stars. You can read more about it on page 126 of book 3, or thereabouts, depending on your edition. So now, transition energy. This energy in conventional physics is called the dark energy. This is the plasmatic magnetic fields that are in motion from principal to matter magnetic field strength. They are so called the transition energy, as energy is defined as the plasmatic magnetic fields in motion. I asked earlier, what is energy? Well, how do you describe energy? But this is what I was alluding to. It's defined as the plasmatic magnetic fields in motion. So that's why the term transition is used. Transition energy is the plasmatic magnetic fields that are moving between the principal matter to matter. Principal to matter magnetic fields. Is that clear? Or are there any questions or comments? That silence is so loud, I can hear it.
I have a question.
Go ahead, please.
I've been waiting because I'm not sure if it's relevant, but the word strength keeps being used, and I have a basic confusion about the word strength as Mr. Keshe uses it, how when energies of different strength don't attract one another, but energies of similar strength, they're attracted to one another. And like when we look at magnets and we talk about their strength, the greater strength always pulls the lower strength to it. So it seems as though Mr. Keshe, when he uses the word strength, he's talking about a different quality. Do you understand what I'm saying?
But the magnets don't always attract. That strength is not just gravitational, it's gravitational magnetical. So it's both at the same time. So it's not quite, that's why the magnet analogy is a little bit not quite the same, because it would be like the attraction and repelling at the same time in a magnet, not just repelling or just attracting. So we're talking about both the forces at the same time. So you have a net resultant that ends up in a positive positioning, unless there's a movement, in which case there's some sort of energy going on.
Yes. So, but when you use the word strength, like if you he always draws the spiral and talks about it starting in the middle with the greatest strength and spiraling outwards further and further, and it's becoming weaker and weaker. And at different points, they're at different strengths, and the different strengths do not attract to one another. So I understand that in terms of they would be different in quality, like the metal doesn't attract the plastic. I know we can make magnets for plastic, but that to me translates to the word quality. They're different in quality or different in essence, so to speak. But are they indeed what we would call stronger? Are just because there's
well, in a way, I know what you mean, and I agree that, in fact, I thought the word color might be a better term than strength in a way, a different color in the sense that how do you measure a maggrav field in a way? It's not just a frequency, and it's not just a certain amplitude that you can measure. And how do you measure someone else's soul? And do we that's a 9 out of 10 soul, that's a 2 out of 10, and you can't really measure that way in terms of, but we can tell when there's a strong presence that someone has. We can tell that, we can feel that strength of a soul, you could say. And
sorry for interrupting. Can somebody look up what does it mean, field strength in physics?
Well, it depends on what field you're talking about, I suppose.
Field strength as a notion, as a concept in physics, has a meaning. So it's not something.
I cannot hear Sandra very well.
Oh, sorry, I have to move to the camera.
Volume.
Okay, sorry. Yes, no volume. Now is it better, my sound?
No, it's about this.
But not best.
Sorry, I didn't do a test. I let it to automatic and I have to put it to manual. I hope now is good, okay?
Yeah, it's quite loud now, yeah.
Okay, thank you. So there is a concept which is called field strength.
Okay, the faster it rotates, it's it's stronger.
So in physics, there is such a term as field, and there is such a field strength, and they apply to different kind of fields, to magnetic field, to electric field, etc., etc. But that may be the term can help to clarifying the last question.
But the thing is, we're dealing with different realms. Like, for example, matter would be just part of the outer part of that spiral, and all of these stronger fields are included in the inner part of the spiral. So it's entirely different sort of dimensions of, or different types of fields in a way. Like they mention in this, that electromagnetic field, or so it can have an electric field strength and a magnetic field strength, or the signal from in radio communications and so on. So there's different types of fields that are being measured. And so in the spiral, like Mr. Keshe draws, can we measure those kinds of fields like we do our electromagnetic fields or magnetic fields and so on?
Certainly, we should be able just to use the proper tools.
Well, the thing is, I don't know if we can access the next highest level of fields. Like normally it's all invisible to us. That's the whole thing. Like we can't see beyond our very narrow range that our amino acids in our eyes pick up on, compared to the wide range that actually exists in the electromagnetic spectrum just alone.
Yeah. Can you use a yardstick to measure the height of a high building, or to measure the distance between Earth and Moon?
Well, that's the thing. As humans, we may not have the yardstick to be able to measure even the next highest level beyond our, physicality stuff that we can measure now and raise in certain fields and that kind of thing.
But there are the methods for measuring by indirect measuring, calculation, and so on. But now that's not the issue. So I came up to complete this word strength of a field with the word as it is used by Mr. Keshe. He says field strength, or field of a certain strength, and that's a common concept in physics. It's not something newly invented. It's not a color of the hydrogen versus the color of the carbon. It's simply the observation that fields of similar or near similar strength will interact.
Well, that's actually how they measure the field strength, is by the color of the spectrum that's given by particular atoms and so on.
Color is related to vibration, and field doesn't necessarily have to vibrate.
Well, the vibration has to do with the local field and conditions of that entity, and the vibration is not something that could be measured independently of the field that it's in, is the thing. The water that you measure, the temperature of water you measure, depends on whether it's in a boiling pot or in a frozen pond, for example.
What's the relationship with vibration? Think about
well, that's what.
Sorry. I put a rhetoric question to give something after. If you would let me, Dr. Gatto, I could finish the idea. Otherwise, the question will hang in the air forever.
Okay, go ahead.
So think about a musical instrument with a string, like a guitar or a violin or a piano or whatever, just a tensed string. Does that vibrate? Not necessarily until you pluck it. And what determines its frequency? They are the forces, the tensions which are inside that string. So now the fields are not the frequency, the fields are not the vibration, the fields are like the forces, like the tensions within the string which can vibrate if you do something with it. So don't confuse fields with vibration. Frequency is not a characteristic of the fields. It can be a manifestation in certain conditions. Your vocal cords are not producing sound unless you press, you give energy to it. I hope that makes it a little clear. I'm sorry for taking so long. Please, Dr. Gatto.
That's a very nice point that you made, Sander, and that helps in my understanding. But let me ask it this way. In the electromagnetic spectrum, we talk of different strengths, but within that...
No, not in the spectrum. There are no strengths in the spectrum. A field, it's a field.
But we call, okay, but...
It can be a magnetic field, it can be an electric field, it can be a gravitational field, or whatever kind of field.
But when we measure the strength of those in our current science, they still are attractive to one another no matter what their strength is.
Really?
Yes, like an electromagnet that is weaker or stronger, they still attract to one another no matter what we call them. You know, one is weaker and one is stronger.
It means they are the same strength, there's the same field strength. It's not the intensity or the volume of the field, it's the strength.
Level. Okay. Okay, very well.
So you have the same field strength if you have a small magnet or a huge magnet, just you have a different volume.
Different volume, okay.
Yeah, different power. So it's strength and power are quite different.
I understand. Thank you.
Okay, so let's try while we are learning to try to figure it out, to place it with some small toys like buttons or plastic cups or matchsticks or whatever on the table to figure it out, or to make a drawing if you can make a drawing, or to model it and try to clarify the concept, to see it from different angles and to find similarities and to find differences. So we can only learn if we can find similarities between the new things and the old reality which we had.
I would be interested, maybe Klaus Dieter has time or has something to say about how he sees the word field strength, or what he is understanding about that.
Who? Oh, Peter, are you asking Klaus?
Maybe he has time to say something about field strength, how he sees that.
Okay, ask him.
Are you here, Klaus?
No, he's saying somebody may have something to say about it.
I have nothing to say about it. I just asked Klaus maybe if he wants to say something through that.
Is Klaus here with us?
Yeah, he's still here in the meeting.
Well, ask him.
Yeah, I'm here, but I was now in another work. What was the question, please?
What's your perspective? How do you see the word field strength?
Okay.
Because we spoke about the physical meaning of field strength and a lot of different measurements, and how you would define field strength.
Yes, I can describe as a pressure of fields, a different pressure of these fields. You have different layers, and it's like the sun. The sun has also a pressure on the atmospheric fields. And for me, when I look into this, when two people or two beings come together, we see how these fields interact. And as we know, the stronger feeds the weaker. I see it like different, what's the real English word? Radius of the fields. And this comes from the original fields. There are different, I feel it like a pressure in the field.
So Klaus,
yes?
Why do two different field strengths then not interact?
They must be near. A resonance, you become a resonance when they are near. It's like when you have two watches on the wall with a pendulum, and they come closer and closer and closer, and then they go the same way. Resonance means when it is near to the other field.
So you described it as the radius of the intensity of the field?
Yes. When I also can annotate, look.
So attraction is resonance.
Here in this thing. And you have, this is stronger and this is weaker. And when fields come together, sorry, there is this interference sound. And here's the most pressure, here's the most interaction. And the farther we go from the center, the weaker are the fields, the field strengths. That is what I see and what I can feel. Is this helpful?
Are you satisfied now? Thank you very much, Klaus.
Very interesting. Thank you.
Okay, that has become clear now. Thank you very much for those who contributed. I was thinking of a break, but we don't have a lot of time, so we might as well finish this. I have only 3 remaining. So what is transition matter, transition mass, and GANs?
Just a second, a little addition about resonance and fields. Please try, everyone, for yourself to define what is a field. That would remove a lot of confusions and misunderstandings. So when we talk about the characteristics of the field, first we have to have the idea of the concept of field. What is what we call a field?
Thank you very much, Sandra. Do you want them to respond?
No, I don't want to think for anybody else. I want to give the inspiration. So what work with your mind you have to do in order to clarify a misunderstanding? Because if you go further after misunderstanding, you have a confusion in one of the terms, then all the rest will become confused.
That's correct. Thank you very much, Sandra.
You have dictionaries, you have encyclopedias, so please look up for what is a field. It can be a little homework. And maybe next time people will come up with more explanations how they understood it each.
Perfect. Let's now talk about transition matter, transition mass, or transition magnetic fields, and GANs. In your own words, please define these terms. Flint, do you see any hands up? Raised hands?
Not any new ones, nope.
Have you raised yours? I can't see, you know.
No.
Transition matter, we just talked about transition matter.
Yeah, we just did. That's the dark matter.
So what would be transitional mass?
Transitional magnetic fields.
What's the difference between those and matter magnetic fields?
You see, it all is related on fields. Until you don't clarify fields, how you want to clarify something which is based on the concept of fields? Magnetic fields, they are fields.
Okay, do you want to clarify?
I just gave you a hint earlier.
Yeah, fields come about through interaction. So when two rays interact, they create fields.
What are rays?
Rays, magnetic gravitational rays.
Are the rays made out of fields, which create fields? So the cat catches its tail in the definition?
It can catch its tail, and the ray here is plasmatic. So you have a ray that creates an image of itself and starts interacting with that image, thus creating a field where that interaction takes place. So it's like did you say what catches its tail? Whatever it is, then
one definition uses the definition of one term uses the other term to be defined by the same, so that makes it a little difficult. So in physics you have a different meaning of fields, in mathematics you have different meaning of fields. A lot of confusion comes because words have several meanings according to the context. So, for instance, in Britannica says, in physics, a field is a region in which each point is affected by a force. For example, objects fall to the ground because they are affected by the force of Earth's gravitational field. Or in Wikipedia, it says, in physics, a field is a physical quantity represented by a number or tensor. And tensor is again an unknown word that has a value for each point in space and time. In simple English Wikipedia, it says, in physics, a field means that a physical quantity is assigned to every point in space, or more generally, space-time. A field is seen as extending throughout a large region of space so that it influences everything. The strength of a field usually varies over a region. And Michael Faraday became the first to coin the term field in 1849. So it's a new word. So really is needed to clarify the concept of fields and to have a visual understanding about it.
The way I visualize a field is it's the radius of interaction of the rays that are attracted to one another. Like in that, in the animation where the two rays come together and they interact with one another, the area of that interaction, no matter how many rays become involved, whether it's smaller or larger, that would be the field, that area of interaction of similar strength rays. Would that make sense?
On Wikipedia, there is a nice illustration about a portion of the vector field that would be useful if it could be presented. So what the heck is a field? So what's a field really?
An area of interaction.
Why it is called a field? What is a field? What is a field outside when you walk in the countryside? What do you call a field?
Well, that's a different definition.
Yes, but there is some similarity.
Well, yeah, I guess the field might have all the same or similar types of flowers or vegetation or something like that.
It's a flat place, isn't it?
A flat place, okay.
So it's a two-dimensional representation of something, for instance. But you can extend that with many layers, like the pages of the in a stack of paper, and make it three-dimensional as well.
Field is where you play soccer, isn't it?
Also.
They're all, it's a place where they're all doing the same thing.
Yeah, it's a place where these rays, both magnetic and gravitational, are playing their own game of chasing each other.
Well, that's a good example. If you think about it, you've got this flat surface, the field, you've got a ball, and you've got, say, two people, two kids interacting. Well, in that, you could say there's a field interaction between the feet of the people and the ball and so on, which there's that two-dimensional field there. There's another field interaction going on between the attention of the people concerned and this ball. So you can virtually feel that tension of the attention of these kids on that ball. They're totally focused on the ball, both of them. And so that emotion and that attention ends up creating that, emotion, we talked about that before, becomes energy in motion, and they go toward the ball and say kick it or pick it up or whatever they're doing in their particular game. So there's an interaction fields going on, and the kids would be aware, one kid would be aware pretty much of the other kid, depending on his abilities to his skills with playing soccer or football or whatever it is, and his ability to keep the ball away from the other kid or give the ball to the other kid, depending on the circumstances. And it's, again, an interaction of fields. It's all about the fields, whether it's between the field, the soccer field, and the ball. That's an interaction of fields. The fields of the ball bounce, basically reflect off the fields of the field or off of someone's foot. And it's, again, an interaction of fields on that level. If you could look at it as plasmatic fields or plasmas that are not combining, they're not of the same level that they want to come together unless, something happens and, there might be some interaction, but generally the ball stays as a ball and your foot stays as a foot. The field may get scuffed up, for example. That changes the actual nature of the objects and their interaction with the fields. But then we have this other whole level of the emotion and the movement of these physicalities due to that emotion and the fields that are going on through that interaction. And what if there's a crowd watching at the same time? That's a different interaction of the fields compared to nobody watching, or just a mom off on the side watching, or there's different field interactions depending on the conditions of that exact circumstance.
Interaction is the important keyword which you told, Ricky. Thank you very much for that. So fields are about interaction at a distance. Another website which discusses the field concepts in physics is the Star Garden. which says in one of the sentences, says a field varies continuously through space and time and creates a condition in space so that the particle will feel a force. So it's about forces and about distribution of forces in space. So maybe that brings you a little closer to the concept of field.
Thank you very much. And we saw earlier that plasmatic magnetic fields in motion. That's how, that's the definition of energy. So these are fields of energy that are in motion. So when they are interacting, it means they are in motion, they create energy, and that energy, the extent of that energy is the field. And where it ends, then there is the magnetosphere. So, perfect. Thank you very much, Sander and Rick, for bringing this up and explaining.
If you look through the videos on the YouTube about what are the fields in the physics, you will find many videos where different teachers from different backgrounds and different part of the world are explaining the same thing. One of my favorites, it's the channel, it's not a place of promotion, of course, just it's my preference for a young man who has a channel named Science Asylum, who gives very interesting presentations in an easy way. Just look through, but please keep it as a homework to clarify everyone for yourself, to understand the basics of what we are talking, which are fields, because maybe, all is explained by fields.
Maybe I've got the part of the nano-technology video of the Keshe Foundation. Maybe we could have a look at that, because it talks about the layers being connected through gravitational magnetical fields. So perhaps I could play a couple of minutes of that, and it might clarify some of these ideas.
Please do. Thank you.
Okay. I think this will do it. I won't play the audio just because it's just the music, but I'll just play through, and I won't play the whole thing, just the part here. I think just before here. Yeah, this is a good place to start. So let me just get it, just bear with me while I get it lined up on live stream so the folks there can see a little better. So I'll just read it here to start out with. The physical matter state is densely packed molecular attachment dependent on temperature and pressure. And we see the physical matter here, which is actually, you could see it as copper atoms represented as physical matter here. Okay, let me play it through this part. Let's go step by step here. So it mentions the monoatomic nanolayers position themselves and are connected through gravitational magnetical fields. The nanolayers share connection to each other, as Shander was talking about earlier, the interaction. Okay, that's important too. They share connection to each other and to the physical matter structure. Nanolayer formation is replacement by positioning of the gravitational magnetic field strength. This occurs from the inner physical matter structure to the outer monoatomic structure. I'll just go back there a little bit there. Atoms from the physical matter reposition themselves within the nanolayer, dependent upon the strength of their gravitational magnetic field. So we talked about strength earlier, and so this indicates the idea that atoms can have different strengths depending.
So Rick, if they're further spaced apart, as in the nanolayers, would that mean the magnetic field then is greater than in the physical matter state?
That seems to make sense to me. Is there anybody else that has input on that? I believe that's the way it goes. However, it may depend on the conditions as well. I'm not clear on that. Let's carry on. Maybe it'll say,
Both
sorry?
magnetic and gravitational are stronger. I think it's both.
Yeah, perhaps, yes. I was wondering about that, and that's kind of the idea that I'm thinking. They each become like little suns. Okay, let's carry on. Maybe it'll explain more. The nanoparticles don't get stuck. They find a gap and accommodate each other. The gaps within the nanolayers are not uniform. The magnetic field gaps hold capacitance and contain a spectrum of fields. This separation gap is energy of gravitational magnetic fields. This is just what we were talking about, basically. The matters part of the nanolayer continuously releases fields to maintain this gap. This release of fields maintains their position and balanced presence in respect to the environment. These released fields amalgamate into the gaps, becoming the center of energy and information. These gaps are magnetic envelopes which contain the plasma. Sorry, I'm just going to go back to that. Which contain the plasma within the nanolayers. So it's an important idea. It's like the matter level stuff basically kind of gets in the way. It's the gap that's in between that's the important part for the plasma. That's the envelope. These nanolayers vary in their gap and therefore their field strength. These layers interact with each other, producing a vast spectrum of gravitational magnetic fields. It's what we talked about earlier. They absorb all the spectrum of the magnetic fields, which is why they appear dark.
This is so timely. You brought this up because we had discussed exactly that. Thank you very much, Rick.
So Rick, could I ask a question about that last sentence?
Mm-hmm.
So the gaps relate to the field strength. Is it the greater the gap, the larger the field strength?
Well, that would make sense. Yes, that's, you know, if these fields they're basically repelling each other but they're also attracted at the same time. I've demonstrated this before using electrostatic charge and little balls, and that they form just like this. They maintain their position, and they want to be close to each other, but they won't get too close. And the ones that are stronger attract the ones to it, but they won't let them, there'll still be a bigger gap in between them. So I think the bigger gap would indicate the stronger fields. Otherwise, you know, they would jam together more. So an automatic positioning system, you could say.
So the larger the gap, the more area, so to speak, there is for all of the things that are being released by the matter, all the energies to interact in, and that creates a greater field strength.
There are envelopes for plasma, so you can think of deeper pockets for plasma.
Yeah.
I think it goes on to talk about that a little bit here. And talks about how to set up with a voltmeter to stabilize the nano layers and so on. And we can see how it's important to have this flow of plasma through the nano layers. Okay, also the idea that it's three-dimensional, not just in two-dimensional. I'll just ask a question, please. Would it not? Hold it, wait a minute. Your audio is terrible, Dimitri. I think it's you. Fix your microphone, please. It's terrible. It's really loud and I can't hear you. Yeah, something needs to get sorted out there. It sounds like a bad connection with the microphone or something's really over amplified. Maybe you can write down your question if you like, or you want to try again? Is that any better? No, it's not any better. It's terrible. No, it's not acceptable. Sorry. Yeah, could you promote my account, please? Sorry, I'm gonna mute you. I'm not sure what you're saying. Write it down, please. It's just not acceptable. It's not acceptable to broadcast that. It just blows people's speakers out and so on. So yeah, you can write down your question. We'll try to pick up on it there, Dimitri. Okay, he says to promote his other account. Okay, gotcha. I think it's been done there.
Yeah, I did there.
How's that? Is that better?
Oh, yeah, that's a lot more humane.
Yeah. Okay, just going back to the. Sorry, I just got to turn the audio off my phone. Okay, so going back to the gaps and the field strength, is it not? You know, we've been talking about the different field strength, and the gap is stronger if there's a larger gap. But have we not got to look at it as taking into account both magnetical and gravitational? Now, the field strength itself, is that actually quantifiable from the gap, or is that gap a result of the difference in magnetical and gravitational fields? A larger gap being higher in magnetical, but a smaller gap being higher in gravitational. And you know, the field strength's kind of a hard one to touch on, because surely it's just a difference in magnetical and the gravitational of that field strength, and not the actual strength of itself.
It may not necessarily be a lack of magnetical or gravitational, but it's always the balancing between the two. They both could be very high, but if there's a balance, that's where the interaction is. The spacing is where the balance is.
Yeah, one way to look at it is each one of these atoms will be basically a different temperature or vibration rate. So some will be shaking a little harder than others, and others will be sort of colder. Some need more elbow room and some need less elbow room. In terms of, you know, if someone is, think of it as a dance floor. Some people on the dance floor just need lots of room. It's like, look out for Joe. He's all over the dance floor and he'll bump into you if you're too close to him. Or, you know, other people like to just dance really, you know, mildly, and they don't want to bump into other people or cause any, you know, disarray or anything. They'll be of a lower energy around them and sort of a tighter configuration, you might say. They might be just as intense and just as focused, but they are not, you know, they don't need as much elbow room. I call it elbow room, which is the gap or the spacing between the atoms. And if, for example, if you're spinning really fast, then you naturally get more elbow room than something that's spinning slower. So if these are spinning atoms, then you think of it that way. And whether it's magnetical or gravitational, it's the combined effect that we're interested in. And I don't know if we can measure exactly the magnetical component and the gravitational component. It may be that you just measure the net result is there's a position, and that's what happens. It's kind of like our position on Earth right now, measuring it's not the gravitational, like the gravity necessarily, and the magnetical, like we would normally think of it. So it's a little hard to measure those components.
Even with us, we are not all equal in size. We live in the same place, but we are different.
Yes.
So that also applies to the nanomaterial, the nano particles.
This is just maybe just carry on through the video a little bit here, because it again gets into the gaps, and these talks about the magnetic field containers because of this three-dimensional aspect. Okay, that was an interesting concept that just came up here. Let me just play through here. The plasmatic magnetic fields are now able to be captured by these magnetic field containers. Plasmatic magnetic fields, the PMF that we were talking about, are now, or is that principal magnetic fields we were talking about before? Plasmatic magnetic fields, I think that's what it should be, right? Now able to be captured by these magnetic field containers. Fields of matching strength with the magnetic field gap are attracted and link up. So the gap, according to what's said here, the gap attracts the fields of matching strength. Let's carry on here. And they link up. And okay, that's it for that part. That was just the excerpt out of another video. So we'd have to get back into the original to get that, because this was a different promo video. It gets into some other things here, which are also interesting and of course related, but not quite to our topic right now. And I'm sure Gatua wants to get back to that topic. Do you want to share again, Gatua?
I have a comment. This is Moshfek speaking.
Mm-hmm.
This field strength. Now let's take the example of iron and copper. Iron has a different field strength than copper. So if you bring a magnet, it doesn't really interact with copper, but it does. If you take a copper tube and a plastic tube and you drop a magnet through it, you will see that there is a delay. So there is a slight interaction of magnet with copper. So the field, there is a difference in field strength between the two, but there is some degree of interaction, very little. Now, if you nanocoat the copper, and if you bring a magnet close to it, that interaction goes up considerably. And this is, I have tested all of these. So if you create a coil and drop a magnet through it, and you see that magnet is pulled much closer to the nano-coated copper coil than just normal copper. So in a way, because of nano-coating, there are certain field strengths that exist within the nano layer which is interacting with iron magnet. So there is some difference between the material copper and a nano-coated copper in terms of its interaction with the magnetic field strength of an iron magnet or steel magnet, neodymium magnet. So this may shed some light from a more practical standpoint of how strength is different from, let's say, somebody mentioned about field pressure. Field pressure, I would think, is something like between two, let's say, pad. We put more GaNs in one and less GaNs in one. Although they're in the same strength, there is a field flow because of the molar weight of one is higher than the other. So there is a field flow. So the field flow and field strength. So the pressure can be raised so that there is a current between the two plates, which is the two pads. So all of these, the field flow, field strength, field pressure, they're all interrelated, and we have to kind of keep all of these things together in the head. So I'm just giving some pointers in terms of practical experiments and some thoughts about various differences between the things that I have come across.
And there's one other factor too, which is if you can just feel the fields, then everything else is irrelevant. All the measurements go out the window if you can just feel the fields. In the case of humans, we can learn to feel the fields. And there's practical examples of that at people that have had their reactors for years, and then suddenly they can start feeling the fields. And so there is hope for those of us who may not be able to feel the fields immediately. But the thing about feeling the fields I wanted to bring up is it's immediate. You either feel the fields in any particular moment, you feel that, you know, certain emotional fields that might be happening or other types of fields that are in the environment, or you don't. And that's kind of the bottom line. As far as that is something that's in the present and in the present moment, and you have to be in the present moment to feel the fields. That's part of the way it works. You don't feel the fields that occurred months ago, or you don't feel the fields of the future that might possibly exist. You're feeling the fields now, basically. So that's the part of the magic, I think, of the way the experiments go with the Keshe Foundation technology. This type of nanotechnology we talk about here is that your fields can interact with these fields. This magnetic field container that we see in the picture that holds on to plasma, energy, and information. Whoa, that's a pretty big statement there, but imagine that our body is plasma, energy, and information, and we can learn to interact with something like what we see here, the gap between these nanoparticles, which holds on to our energy field as it's being created. So what we're putting out gets put into those nanomaterials when the nanolayers are being created. And that goes back into the GaNs, when the GaNs is created from those nano-coated copper plates that we've already put hopefully our love and intention into, because that's the important time to be doing that during that creation process. So just a reminder anyways that that interaction, you can see how it's, plasmas interact. That's the biggest thing about plasmas. They have fields, and we can interact with fields. And it doesn't have to be by, eating it and so on. We can interact with fields without touching or smelling or without any of our direct senses, actually.
Rick, the feeling of the fields, actually, this makes things really easy, which is a very important point you just raised. And I really like that you brought this up. And what we are doing is thinking about the fields But if we think about feeling, then that makes it really hard, because thinking is a much laborious process, but feeling is a much more direct process in a way. We are using the higher strength field. So anyway, I just wanted to bring
Well, that's
that
right. I'll give you an example of the scale that we're talking about. I think I do a little thought experiment recently with people. Think of putting yourself on the sun. You're visualizing in your mind, close your eyes and boom, you're on the surface of the sun. Wow, it's all, hot and so on. Okay, bang, come right back here into the present moment again. Okay, now you've just gone from here to the sun and back in a period of a couple of seconds. Now, the light that normally travels from here to the sun or from the sun and back has to travel for 8.5 minutes each way. That's 17 minutes it would take light to travel that same distance. And we just did it in 2 seconds. Wow, that's pretty amazing. But feeling the fields is another gradient, another scale faster than that, because it's right now, right in the moment. There is no delay. There's no feeling the fields a few seconds ago. No, you're feeling the fields at this moment. It's like a field detector, a magnetic field detector doesn't detect the fields that happened minutes ago or the fields in the future. It detects the fields right now, right? It doesn't, that's the way a field detector works. It's the field right now, not the field before, not the field after, not a dream field of the past or this fantastic, great field of the future. It is the field right now. And either your detector detects it or it doesn't detect it. But one way or the other, it has to detect it in the moment. It can't be a detecting fields that are non-existent in the past, because the field is gone once the moment is past, so to speak. So it's interesting to look at it in terms of scales that way. And it's way, 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 did I say way enough? Faster than the speed of light.
You missed the teaching last week, Rick.
Which one was that?
By Wednesday, I think, Caroline teaching.
Okay.
We learned how to feel the field.
For those who want to practice, the practice with feeling the fields of your soul. And thank you very much, Mosfek and Rick, and all others who contributed. We are running out of time, I believe. So I'm going to conclude shortly.
Okay. Do you want to share there, Gatwa?
Yes, let me do that. Thank you. Thank you very much, Rick.
Thank you.
Yes, next time we'll continue with this. I am not going to go through these 3, so we'll start there next time. But let me summarize. We have done the questions. Today we just introduced the topic of 11 basic plasma science terms. We covered 8 of them in depth. There were a lot of, there was hesitation in the beginning, and then a lot of people contributed. So it became very interesting. Good questions came up. We had a good discussion in our own words, and we watched a few animations. So with definitions, we looked at the basic plasma science terms of 8 of them. And then we'll continue from there next time. Thank you very much indeed. And I appreciate very much all those who contributed. Over to you, Flint.
Yes, thank you, Dr. Gatwa. And Rick, wow, thank you.
You're welcome.
So this will conclude part 2 of Exploring Plasma Science, Monday, February 12th, 2018. from the Keshe Foundation Spaceship Institute. So please join us tomorrow afternoon for the 27th One Nation, One Planet, One Race for World Peace. And then again Wednesday morning for Rick's Plasma Reactor Group, and then also Thursday morning for the Public Knowledge Seekers Workshop number 211. So those are our public teachings this week. Hope to see y'all in each one of those. Again, thank you very much, Rick, Shander, and Gatwa.
You're welcome. Thank you for a great show today to Gatwa and Flint, Shandor, and others.
Yes, thank you very much, and good night. I mean, have a good day.
Yes, have a good day, everyone. Bye for now.